Okay, so we're beginning to solve trigonometric equations as part of AS Excel trigonometry. Just thinking back a while before we do that, a very simple Stoke-Artara trig question you could have been asked at GCSE. There's a right angle triangle, you're quite familiar with that. It's a sine ratio we're dealing with, and I'm sure you'll be able to see that sine theta equals to a half. When you work out theta, you would be working out well, there's different ways of writing it. Sine minus 1 is an old-fashioned way. The calculator says inverse sine, the opposite of undoing the sine function. At Excel, use this term, and many mathematicians use the term arc sine. Okay, to mean inverse sine. Okay, in any case, we can say that theta is arc sine a half, and we're working in degrees, gives us the answer 30 degrees. So this angle here is 30 degrees. Okay, now, thinking of the trig graph, our 30 degrees goes there, because we're basically looking for the points of intersection of the line y equals half with the graph y equals sine x. And we can see that 30 degrees is the only one we're really interested in this problem, because it's not possible to have angles of greater than 90 in a right angle triangle, or angles between more than 180 are not relevant in triangles, and angles less than 90 are not. You're never going to come across in a right angle triangle. So we're only interested in that value. Okay, that's the value calculator gives you. The value that the calculator gives you when we're dealing with sine is called the principal value, and the principal value will be a number which lies between 90 and minus 90. Okay, so that it will give you one value only. In this particular trigonometry question with the triangle, it's the only value we happen to be interested in. However, there are many other values, and you will be able to see them from the graph. We've got 150 there, we've got 390 there, we've got 510 there, and we've got 750 there, for example. Yeah. And we've got negative values as well, minus 210, and of course you can carry on forever. There's an infinite number of these. Or what you might be asked for is numbers within a particular range. Which numbers, for example, if x lies within the range 0 to 720, we would have the solutions theta not only equals 30, but we would have 150. We would also have 390, and we would also have 510. So we've got our four values within that given range which satisfy this trig equation. Very simple trig equation, sine theta equals to a half. Of course, in terms of right angle trigonometry, it's only this first one that we're interested in. It's called, this value here is called the principal value, the value the calculator gives you, and we can work out all the other values from that. Okay, so that's how it works. You can always use the graph to solve trig equations. You can use that graph, and some people do. However, sometimes it's a little bit slow, so we want a shorthand, quick way of working out the values, and this is where this formula comes in. This formula here. Just explain how that works, and then we will solve the equation sine x equals minus 0.4 looking at the graph and using this method of using the formulae. Okay, so let's just rub these values out. Principal value. Okay, let's rub those out for the time being. How does this formula work? Well, principal value, of course, is this one, and that's the value calculator will give you. Principal value. You get a lot of other values by adding multiples of 360. So we've got x equals to a principal value 30, but if we add 360 to it, we get this value here, which is 390. We would get more by adding 360 again, but say presuming we're only one solution's within the range 720 to 0, we won't be asked for all of them. We'll be clear which ones we want. So imagining we're only interested between 9 and 720, we've got 30 to 390. But of course, that isn't those aren't the only solutions. You've also got one other solution, which is 180 minus a principal value, which is that one. Okay, which in this case, 180 minus a principal value, 180 minus 30 is 150. So we've got 150. But we don't only have that value, we have we could keep on adding lots of 360 to get more values that actually satisfy the equation. So 150 is 1. Then add on another 360 to that, and we get that answer 510. And let's imagine, in this case, we're not interested in numbers below or above that. Of course, there are negative solutions as well. For example, this one, we could be going by doing 180 minus a principal value, that 150 here, and then taking away 360 to get this one here. Okay. Of course, you could get these from the graph, but this method can be a little bit quicker. Just to show you what I mean, let's just use this method, or both of these methods, the graphical and the formula, to solve the equation sin x equals minus 0.4. And we're basically following this process here. It's described on the sheet. Okay, so we first find the principal value by doing the arc sine. At this stage, what you might want to do is pause the tape and see if you can actually solve this equation between 0 and 360. Okay, if you 720, say, there will only be 2 solutions between 0 and 360. There will be 4 between 0 and 720 because the period is 360. Okay, so if you want to pause the tape now, to see if you can find the 4 solutions which lie between 0 and 720 for this equation. Okay. Right, okay, so this is how it's done. Find the principal value. Okay, the principal value, arc sine of minus 0.5. Make sure that your mode of 0.4, sorry, make sure the mode in your calculator is in degrees. So we get the principal value is minus 21.8. We've also got 180 minus the principal value. Watch out for the double negatives here, because that gives us the answer, that gives us the number 201.8. Okay, so our solutions are, if we put it into this formula, principal value 180 minus the principal value, we've got the principal value is minus 21.8, and 180 minus the principal value is 201.8. But of course, we can add on or take away multiples of 360 to those values. In this case, I'm only going to add 360 to it because I'm not interested in values negative because of the inequality, this side of the inequality. So I'm just going to add on the 360. So minus 21.8 plus 360 is 338.2. And the 201.8 plus 360 is 561.8. And we can see these on the graph. As I say, some people just revert to the graph. It can be a little bit slow. So what we look at it here is the graph gives us this principal value here, which gives us minus 21.8. Okay, so minus 21.8, and then we add on lots of 360. So that gives us that value there, which is our 330.8.2. At this point, you may have realized we haven't got all of our solutions. Okay, because there's this one. We can add 360 again to this solution to get the next one, which is 698.2. And in fact, in this particular case, the principal value is not a solution that we needed to offer in our final answer. You wouldn't lose marks for writing it down, but it's not actually needed in the final answer because we don't want any negative solutions, and our principal value, the thing that the graph gives us, is negative. Okay, so we have all our solutions, and we best write them off properly in order now, which is our first solution is 201.8. Our second solution is 338.2. Okay, this is this solution here. Okay, and then we've got 561.8 and 698.2. Okay, those are our solutions. So from the top branch, we got that was the principal value here. We got that one, that one, and that one. Okay, so in other words, 338.2 and 338.2 and 561.8, and we get the other solutions by looking at this branch here, which is 201.8, and finally 360 plus that, which gives us this one, which is 698.2. Okay, so we've got all those solutions from using our formulae. Okay, let's stop it there.